Let's do problem 3 on the practice exam. So here it is, it's a rational function question, and we've got this nice rational function here, and we're just going to go through and answer these basic questions about it. So the first thing is, what's its y-intercept? And the way to get the y-intercept for any function is just to plug in 0. So it's easy to see that if you plug in 0 into this function, everything is going to vanish except for -7 over -4. Okay, so the answer to A, those negatives cancel, and the answer is just 7 over 4. Okay, great. And now it says, what are the x-intercepts? So if you have a rational function, you want to find the x-intercepts. It's always just the roots of the numerator. The roots of the numerator. Okay, so that means the roots of this thing on top, which is a quadratic. And I am not immediately seeing how to factor it, so I'm going to use the quadratic formula. So that will give me 6 plus or minus the square root of 36 plus 4 times 14. So what is 4 times 14? I need to do it over here on the side. This is 1, 6, so it's 56. Okay, great. And divide through by 2a, and so that is 4. So let's hope this comes down to be a nice number. So I've got stuff here, and when you add 36 and 56, what comes out? It comes out to be 92. And this is over 4. And I know, because I did this earlier, that 92 is 4 times 23. Okay, and so that means that I can rewrite this thing as 6 times plus or minus 2 times the square root of 23, and then I can make it a little bit nicer by canceling out some evenness. So this becomes 3 plus or minus the square root of 23 all over 2. Okay, so those are the x-intercepts, and I will write the answer just like that. So the x-intercepts are x equals 3 plus or minus the square root of 23 over 2. And we know that that's really giving 2 of them, right? Because one for the plus sign and one for the minus sign. Maybe we should go down and start making little ticks on we have to graph it, you see, for f there. So we should go down and start labeling these things. So the y-intercept is at 7/4, so that's a little bit less than 2. Okay, and what did we just have? We had 3 plus or minus the square root of 23 over 2. Let's see if we can figure out what that is. So the square root of 23 should be approximately, let's just kind of figure out ballpark what it is. So it's going to be bigger than 4 and less than 5. It's going to be, okay, so this is just slightly less than 5. So if we add 3 plus something that's approximately 5 and divide by 2, we get something that is a little bit less than 4. So I'm going to say it's right here. Okay, and now what happens if we choose minus? Then we get 3 minus something that is a little bit less than 5, and we divide by 2. So if we do -2 over 2, it's going to be just about here. Okay, it's just going to be about there. So we've got some x-intercepts and some y-intercepts. Alright. And okay, so C says, give the equation for any horizontal asymptote. That's easy, because you can just see that the degree of the thing on top is 2 and the degree of the thing on the bottom is 1, and so we know a rule that says that means that there are none. There are no horizontal asymptotes. And give the equation for any vertical asymptotes. So this is easy too. Vertical asymptotes are just the zeros of the numerator. The zeros of the numerator, and the numerator is very simple in this problem. you can see that the only zero in that numerator, or the only thing that makes the numerator 0, oh sorry, I'm stupid, it's late at night. This is the denominator, the thing on the bottom. So the only thing that makes x minus 4 0 is 4. Okay, so 4. So x equals 4. And let's go down here and put a little tick mark at 4. Okay, so I'm going to have a vertical asymptote there. So let me get some little tool here to help me draw a straight line. It's going to go through there like that. Alright, so I have to put a vertical asymptote there. And what else? It says give the equation for any slant asymptotes. So this rational function does have a slant asymptote, and we can find out what it is by doing polynomial division. So this is a simple one, so we can do synthetic division. So what I want to do here is, maybe I can erase this and make some space to do it right here. What I want to do is send 4, still got this tool on, so I turn that off. I want to send 4 into the top polynomial, so 2, minus 6, and minus 7. And what happens? Bring down the 2. This gives me 8, this gives me 2, this gives me 8, this gives me 1. Okay, so what this means is the remainder is 1, and it says that 2x squared minus 6x minus 7 divided by x minus 4 is equal to 2x plus 2 plus 1 over x minus 4. Alright, and this shows you why it has a slant asymptote. It's because as x goes to infinity, as x of our rational function goes to infinity, this remainder part goes to 0, and so far away from the origin, the function just acts like this. So this line is giving the slant asymptote. And so knowing what you know about lines, you know that this is a line with slope 2 and y-intercept 2. So let's go down and see if we can put that on our chart. So the y-intercept of the slant asymptote is 2, and it has slope 2. So what does that mean? That means you go over 1 and up 2. So now I need to get my, probably a darker shade, and let me get my, or maybe a light shade is okay, because it's not supposed to be part of the graph. It's just to help me draw the picture. And let me get my ruler. Okay, and so I'll start somewhere like here, and that is going to be the slant asymptote. Alright, so haven't started graphing the function yet, but we're getting close. We're supposed to write that down somewhere probably. So the slant asymptote is y equals 2x plus 2. And now I think the only thing left to do is graph the function. So graph r of x. And that's easy. Okay. By the way, we know that each of these x-intercepts has multiplicity 1, right? Because it was a quadratic on top. And we factored it into 2 different linear roots, so they each had multiplicity 1. So that gives me a strategy for graphing this thing. I'm going to start off here on my slant asymptote, and then I'm just going to make my dates with my x-intercepts and my y-intercept going straight through, and at the end I'll go back to my asymptote. So I have to go through there, through there, through there, and then I have to go down at the vertical asymptote, like that. Okay, and now there's not anything up here, but when it comes down from the vertical asymptote, it's going to come down from infinity and pick up along its slant asymptote and go off to infinity like that. Okay, and I just know that because it goes back to its asymptote far away from the origin. It misses it and wants to be reunited with it. And I know that So maybe you want to argue with me about it coming up from the bottom after the asymptote instead of down from the top. But it can't come up from the bottom, because if it came up from the bottom it would have to have another x-intercept, which it doesn't. So we're right about it coming down from the top like that. And we're done with this question.